So what you saw today was how we built SwiftUI views. Firstly, you saw all the refactorings that already exist or how to do them manually. So you saw how to use view modifiers and how you can use them to customize SwiftUI's view appearance. I showed you how to make use of the SwiftUI environment. I showed you how to add hooks so you can implement custom functionality and add that to your views, Xcode component library, how to publish that to GitHub, and maybe blew your mind by showing you how to avoid using graphical Git clients. And then I demonstrated how this is a drop-in replacement. All right. Good afternoon, everyone. I'm super happy to be here. It's my second time, so in that survey, I was in that group. And also, I'm in Team Sticker. So my name is Peter. I'm a developer advocate on the Firebase team, Team Sticker. And you might be wondering, why is a Firebase guy working at Google giving a talk about an Apple technology? Very good question. So let me tell you a story. When this happened, when WWDC 2019 happened, I decided to leave my previous team and join the Firebase team because of SwiftUI. So before I already worked at Google, I worked on the partner developer relations team, and that team works with the top 1,000 app developers across all the platforms that that Google has APIs for. So that means Android, the web, and also iOS. And when this happened, I thought, wow, so SwiftUI makes building amazing apps a lot easier. Writing UIs in UIKit, and I think most of us will agree, is a lot more complicated than SwiftUI. And I thought Firebase as a toolkit is something that makes developing apps also a lot easier on the back end. So why not bring both together? And that's why I applied to the Firebase team. And for those of you who don't know, Firebase's mission is to help developers succeed by making it easy to build and grow apps. So we've got a lot of backend services that you can use. If you've been at the one of the previous sessions about AWS Amplify, we've got something similar. So to make it easy to connect your application to a backend. And someone else said, the best way to build an app is with Swift and SwiftUI. So any idea who said that? Show of hands? I think his name is Kevin. So it was not me, but it was a guy from Apple. And this is why we're here. I think Firebase and Apple SwiftUI go together well. And today I'm going to show you how to build better SwiftUI views. And then one more point. I wrote a book titled Asynchronous Programming with SwiftUI and Combine. The original title was SwiftUI and Combine, and then I think you know what happened. All right, let's start with Hello World. So if you build a SwiftUI application, what will happen is that, first of all, you get this. You get this source code, and it looks like that in your preview. And now let's take that source code and build it into something more complex. So let's begin by adding some state. So we're going to use the state property wrapper to connect to a collection of books. And then we're going to turn this thing into a list. Now, it's a list. It doesn't look right yet, so let's work on that. So first of all, let's rearrange the icon. Let's put the icon to the left, like this, using a H-stack. Next, let's bind the state. So instead of saying hello world, we're going to display the book titles. Then we're going to use the book images. So instead of using the SF symbol globe, we're going to use a real image using the cover that we get from the book. We use the resizable modifier, change the aspect ratio, and change the frame to make it look nice. But it still looks a little bit crappy, so let's fix a couple of things. So first of all, embed this one in a VStack. And then let's add more details. So we want to see the author and the number of pages, like this. And it doesn't look any better now. So let's fix the alignments. There are two places. So first of all, the H-stack and the V-stack. And this looks a lot nicer. So the image and the text are aligned at the top. And all the labels are left aligned. So this looks a lot better. But there's a problem. You probably can't spot the problem because it's not a problem per se, but that's the problem. So we're repeating ourselves a lot, and you can imagine this is a relatively simple UI, but what if it would be a more complicated UI? So you would have like this giant file with all those things in it. So let's use some refactorings to make this better. And I'm going to show you how to use those refactorings to turn this into a more reusable component. So let's first take this H-stack and bring it into its own component by using the subview, extract subview refactoring. And that's actually a built-in refactoring. So we'll do that, and then we will have a separate view, which is called book row view, which is being used in the list. So that looks great, but if you look very sharply, you will see that there is a problem, which you will see in a moment after we fill our checklist here. All right, so we've used the extract to subview refactoring, and that the recommendation is to use that for reusable parts in your UI. For example, this row that we just saw. All right, so now to the problem. All right, so the refactoring, I mean, it's great that they do have the refactoring, but they, I think Apple is known for sweating the details. That maybe somebody had to go home and look after their children. But it's still missing, right? So what we need to do is have a variable on our book row view, and then we will need to pass it from the list. All right, so that's fixed. So, and I thought it would be nice to have this wish list of things. So if anybody from Apple is watching, hello, or is in the room, here's a wish list. Maybe all of us might be interested in having those implemented. All right, so extract to subview should work all of the time. That's one of the wishes. And then it should also refactor the dependent properties. Cool. Oh, and there's one more. It would be really nice to have an extract to file refactoring like other respectable IDEs have. All right, so this is how it looks like, and it's still not looking great. So, what's with all the white space? Like this. Where's that coming from? So this is coming from the fact that SwiftUI uses just enough space to make this work, right? So we've got hugging views and expanding views, and the H-stack is a hugging view, so it tries to use as little space as possible for everything that's in it, and that is why it tries to make just enough room for the longest label in there, so for the author name, and that's why we've got the white space left and right. We can fix that by adding a spacer at the end. That's the simplest solution to do that. And what will happen is it will just squeeze everything to the left, and now it looks like we want it to look. Cool. All right, so now let's do more refactorings. First of all, I want to refactor this text label here and put it into its own subview. So what I'll do is I'll define a new local property, a computed property. I'll say this is some view. Oh, this is some view. and I'll just move the code up there. And I can do that because I access the book variable, the book property from within, so it's in the same scope, so that works. And then down there in the VStack, I can just replace the entire thing with a call to title label. All right, so we've now, there's, oh yeah, and I did that manually. So, there is no refactoring for that. So here's another wish list item. Cool. What about these here? So they access different things. So instead of accessing just one thing, the first one accesses the author, the other one accesses the page count. So we can't move that into a computed property, but instead it needs to be a function. So we will implement a function called details label, and we will pass the text that we want to display, and then it returns a view, namely the text view. And because this is not a computed property but a function, it looks slightly different, but it does the same. Cool. So we can replace all of this with detail label, and now we can call it like this, and our call site looks a lot simpler now. Great. So we used the extract to subview refactoring. We used the extract to local subview refactoring. I recommend to use this whenever you want to access a property of the parent view, like we did for the title label. And then we use the extract to local function refactoring manually for doing, for the details labels. All right, so next slide. Okay, great. So extracting to function, that's the refactoring you should use when you need to access something that you need to do some computation on, and you want to essentially parse something from the local scope. All right, so now you've seen the basic tools, and now we're going to build something more complex than just this list view item. And I thought it would be nice to build a reusable text input field with a floating label. And please bear with me. I know that this is a pattern that we know from the web, and some people might complain about that, but it is mostly to teach you how to do that. And besides, I've seen other apps using that as well. So, leave your concerns at the door for a moment. Here is how it looks like. So I want this to be a drop-in replacement for TextField. So wherever I use TextField, I want to be able to use my custom component. And I want to be able to support mandatory fields. So I want to be able to say this is a field that a user needs to fill out. I want to be able to do custom validation for things like validating that this is a proper address or an email address or whatever. I want to be able to have this floating label, so whenever the user starts typing, that the hint from within the input field floats up and becomes a label so that they can still see what they are supposed to enter in this text field. And I want to support all the things that we know and love from using TextField, like being able to style it, being able to do focus handling, and there is another feature. I want to be able to have a clear button, like the one that you see at the right end, so that the user can just click on the button and it will clear what's written in the field. Great. So here's how it looks like for a regular text field. And I want to be able to just drop in that second line where essentially it's just changed the name of the class, of the view. So let's have a look at how this looks in the source code. So you can navigate into the SwiftUI source code, well, at the interface of the source code, because it's not open source. That would be another item for the wish list. Make it open source, please, so we can understand, is it a bug or is it a feature? All right, so this is the signature of the text field, and I want my text input field to behave exactly like that. So what we'll need to do is we'll need to make sure that we've got this initializer here. So if we didn't have that initializer, we would have to call it using text input field, title, colon, and then the title, and then text, colon, and then the binding. So we don't want that. We want to skip the title, and that is why we have the underscore, and that is why it looks like this. All right, so this is the beginning of structuring this as a view. So we use a Z-stack so we can overlay a text on top of the text input, and the text is going to be the placeholder. So the first thing that we need to do, or want to do, is use a different foreground color. So I want to use a different foreground color if the text is empty than when it's not empty. So that's the first thing that I'm going to do, and as you can see in the video, in the animation, it doesn't look great yet, so we'll have to do something about it. So the first thing is to animate the offset. So we will change the offset depending on if the text is empty or not, and that will make the label float up, but it's still too large, so we'll have to change the scale when it moves up. And also, that's going to be animated because everything that's in there is animated. Cool, so that's that. What about the clear button? So first thing, let's build the UI for it. So we are using this trick, or this technique I showed you at the beginning, to have an internal view that is part of our outer view to define this clear button. So when the clear button is visible, we want to have a spacer to push it to the right. We have a button. It doesn't have a text, but it has an image inside. We use gray as a foreground color. And if the button is hidden, we will just use an empty view, so nothing is shown. And then we use an overlay to put that on top of our text view, and a padding to pad the text field from the right, and that makes sure that we don't have clipping when we enter a very long text. So, Marin, you were the one who asked about the Hitchhiker's Guide yesterday, right? There you go. All right, so let's now customize the view. So you saw how to build that, that button. But now, how can we teach this text input field to have this view modifier to hide or show this clear button as we need, right? So first line has the clear button, second line doesn't have it. So how can we do that? So the first thing that we want to do is we want to use the environment, the SwiftUI environment, to do that. And you will see why we're doing this in a moment. So first thing, if you want to use the SwiftUI environment, is you'll have to create an environment key and an extension on environment values. So the environment key is used to basically read and write into the environment. And we will also use it to define a default value. And then down there in the environment keys, you can see that whenever I use this computed property, it will either read from the environment or write into it. Right. Then we'll have an extension on view, which gives us this clear button hidden view modifier. And inside the view modifier, all we do is we write into the environment to connect to this property key that we defined before with this / clear button hidden. Once we've got this, we can update our code and connect it to this property. And you can see that I'm using @environment to connect to the clear button hidden. So I can use this variable inside my view, and then when the clear button is not hidden, I can show it. And if it's hidden, I'll just show an empty view. All right, so this is how it looks like. And now you will see why we use the environment to do that. Because in the inner part of this section, I use clear button hidden to show the clear button for one of those clear buttons. But at the outer part of the section, I'll say I want it to be shown for all of the items. So the very last line, this one here. This one says, please show the clear button, or please hide the clear button for all of the fields that are part of the section. And then for those other 2 lines, I'll say, well, let's invert this decision and show it for those 2 lines. And that works because the environment trickles down, right? Everything that you write into the environment trickles down the view tree. So when you define something higher up in the environment, it will be defined on this level, and then it will trickle down to all the other views that are children of that parent view. And that's what we're using here. Cool. So now the question is, can we still style our views? Will things like disable autocorrection or keyboard type still work? Because we created a new view, and for the user, for the developer, can they, do they need to, poke through the thing to control what's going on inside, or can they just use the outer interface to do that? And also, will we have to expose all of the properties of those inner views manually, right? So, for example, on the text input, I want to be able to say, well, I don't want autocorrect to kick in for this input field because of reasons. So, will I have to expose those properties to the outside world? So, the good news is, no, we won't. Everything will still work because of the environment. So let's have a look. So we can do things like disable autocorrection. We can do things like setting the keyboard type and everything else that you might want to do with the text field by just applying the view modifier on our new component. And because of the SwiftUI environment, those values will trickle down to all the components within this new view that we created. Cool. So what about focus handling? So let's add a focus state to our view here, and then define focusable field, and I decided to just use the first name and last name so that you can still read the slide. So I'll add the focused view modifier connected to the $focus property, and it works like a charm. Again, all of this works because of the SwiftUI environment. Great. So we've established that our approach of building new SwiftUI views works. So let's add more features. Let's add validation handling. So now things are going to be a little bit more complicated because up until now, we've basically just defined simple properties like showing or hiding the clear button view. But now we want to be able to hook in additional functionality, right? So we want to be able to basically hook up a closure that says, well, in the closure, we want to perform this validation handling. All right, but first, let's do the simple thing and say, let's build a mandatory field. So again, this should be no news to you, so you should now know how this works. We will be using the SwiftUI environment to define a key and manage that key to track this is mandatory property. So we'll just define a new value up there. And this is how we perform the validation. So this is the business logic that goes into our view. So we'll say if the value is not empty, then it's not valid. And then we'll display a validation message or not. And then we also need to show this on the UI. And here's a new text label that we'll be using for that. So if the input is not valid, we will show this text. We'll use a foreground color of red. And this looks very similar to this floating label that we've used before. All right, and then on the text field, we'll hook into the onAppear and onChange of events. So to make sure that whenever the value changes, we perform the validation, but also when it first appears, right? Because it might be empty when it first appears, and that might or might not be valid. So Next step, how do we expose this state, right? So we do this, this validation now, and our view now knows if the input is valid or not, but the developer might want to do that on the outside as well. So they might want to know, oh, is the input valid? Because they might want to enable or disable the submit button on the form. All right. So what we want to do is we want to have another binding that will expose if the view is valid or not, like this. And then we can hook up our button and say, well, it's disabled when the input field is not valid. Cool, so how to do that? So first of all, we're going to add another optional parameter to our initializer that takes a binding to a Boolean, and then we can write back to that value. And to do that, we will add this didSet property listener to our isValid property. So whenever that changes, the didSet will be kicked in. Then we change the isValid binding property. That will update the binding, and that will go to the outside world. It looks a little bit complicated, but it works seamlessly. Cool. So now let's do the advanced stuff and implement custom validation. So I want to be able to say this is a valid email address or not, or I don't know, I want to be able to say you need to enter a number, but the number must be bigger than 17 and smaller than 42 or whatever. So custom validation, that's what we want. So, and this is how I want my call site to look like. So I want to be able to say, here is an onValidate view modifier. That modifier has a closure that should be called I want to receive the current value, and then I want to do some checking, whatever, and I want to return whether that's valid or not. Okay, so how can we implement this? You guessed it, we'll use the SwiftUI environment. So all of this probably looks familiar by now, but there is one difference. Instead of having just a simple Boolean or a string, we now have a closure that we register. So we will write this closure into our environment. And then this is how we can call it in our code. So inside the validate function, we will say, okay, so now we will call this validation handler if it's present, and then we will decide if there is a failure and update our error message display accordingly. And that is how we do the custom validation. Cool. So how can we reuse this component? So we've now built it, and that's great. So it's useful for us, but we want to reuse it in our projects, in other projects, and maybe we want to share it with the outside world. So first of all, let's look at how we can reuse it locally. So first of all, we want to create a new package to host the code that we developed. So we're still in this project where we developed all of this, but instead of having it in our in this project, we want to move it into a Swift package. So first of all, we will create a new package. We need to make sure that this is part of our project, and it's added to the correct group, like this. And then we will use the extract into package refactoring. Just kidding. It's not there. It would be so nice, wouldn't it? All right, so we do that manually, and we rip the code out, we put it into the package, we resolve all the compilation issues, we take into consideration that the API must be public, right? Because before it was just package internal. So do all of that. Great. And now, for something really nice. So you probably know the Swift component library, the SwiftUI component library. Press the plus button up there, or Command-Shift-L, I believe it is, and then this window pops up, and you've got all those things that you can use. You see all your Swift views, SwiftUI views. You've got snippets, you've even got SF symbols in there. It's amazing. It's a great tool. So let's put our new component in there. And there's actually there's actually an API to do that, right? So you can implement a library content provider, and that library content provider has two methods that you implement, one for the views and one for the modifiers. So in the views method, you will just register all the views that you want to expose to the library and say, well, here's a text input field, and these are the default values that I want to define. So when the user pulls this out from the library, these are the values that appear in the code editor. And for the modifiers, you can do the same. So I can register code that I want to appear in the editor when the user says, I go into the library and I pull out this clear button hidden view modifier. Great. Really great. And this is how it looks like. Which is a bit disappointing because there are no details, there is no icon. Yeah, so I think it was the end of the quarter, so the person implementing this didn't finish. Sorry for the snark. You know, I work for a big company. It's stuff works like that at big companies oftentimes. All right, so we want, yeah, here's the wish list. So we want more refactorings. We want the extract to package refactoring, and we want rich previews for Xcode component library. All right, so we've shared it locally. Our team is happy. Now let's share it globally. Let's share it with the world. We're happy. We want to do the right thing. We want to contribute to the open source community. So let's put it on GitHub. So what we'll do is, so I created a repository, and I don't know, who knew that you could do that? You could just drag files from the Finder into a repository. It's crazy, right? It works. And it creates a commit, processing your files, and there you go. It's amazing. So what did you say? Git UIs for sissies? Yeah, because you can do that. All right, cool. So, and now let's use this in an application. So, and I'm gonna show you, so let's do some live coding. I don't have the same live coding chops as Shai, so, and let me make this a little bit bigger for you. All right, so this is a sample application. It's got a login form, and in this login form, I want to use that. So the first thing that I need to do is I need to add this to my packages. So let's first go into GitHub. And then I'm going to copy the URL, because for adding packages, the easiest way to do is just grab the GitHub URL, go back into your project, then do a right click and add packages, and paste it into the search field. Wait a moment, and then we will see our wonderful README file. So that's why you should have a proper README file that has a nice logo, so people will feel welcome. All right, add package. I'll add it to my project like this. It resolved. And now I can go into my code and then look for the input fields. So here we've got the text field, and I'll change this to text input field. And then it will probably not compile because it couldn't find it. And then hopefully this refactoring here works, this quick fix. And it did, so Xcode added the import for me. And then I can go down, and I've got a secure input field as well. So I will change that. Great. So let's now run the application. Build succeeded, there we go. And now I'm gonna move this to the side like this. All right. So here's it's a simple note-taking application. I'm not logged in. It's connected to Firebase authentication, and you see a lot of anonymous users. But there's also an email-based user, test@test.com, and I'm going to sign in as that user using our new input field. So now you will see that we've got this nice floating label, test@test.com, password, log in, and we're logged in, and we can see the text. So let's try that. Repeat after me. Swift. Swift. Great. And let's update that. And then you can see on the right-hand side that this uses Firestore, so it updates what's in the database. And because this is synchronizing live, I can update this as well. And then once I hit save, oh, it's not in this screen. It doesn't edit, but if I do it here, it will edit. There you go. So that is Firestore's real-time sync. All right. And that was our in-place drop-in replacement. So we don't need that video. So what you saw today was how we built SwiftUI views. Firstly, you saw all the refactorings that already exist or how to do them manually. And you saw that Apple maybe, hopefully, I mean, WWDC is right around the corner, so maybe they'll ship all of these. Leo, it seems like you don't believe that. So you saw how to use view modifiers and how you can use them to customize SwiftUI's view appearance. I showed you how to make use of the SwiftUI environment. So until I built this talk, I'll be honest, I thought, well, okay, so we've got the Swift environment, a SwiftUI environment, so what? I can pull stuff down from there, like the dismiss activity and stuff like that. Nice. But I was not aware of how powerful this really is. So, when you build something, consider using the SwiftUI environment. I showed you how to add hooks, so you can implement custom functionality and add that to your views. I showed you how to reuse it locally. We had fun with the Xcode component library, and then I showed you how to publish that to GitHub, and maybe blew your mind by showing you how to avoid using graphical Git clients. And then I demonstrated how this is a drop-in replacement. And that is it. If you are interested in more information, this is the GitHub repository where the code for it lives. And there is a YouTube video series that I recorded a while ago that goes through everything that I talked about today in more detail. It has Lego in it, so I do recommend it. All right, that's it.